Ooh, hello, hello. Welcome to my Mad Lab. I have the lighting just for dramatic effect as I see if you guys can hear and see me. So tonight I'm using some different camera and audio stuff a little bit. Some I'm not too pleased with and some I am. But can you see? Can you hear me? I'm going to go ahead and turn the light on here. I'm blind. There we go. 5x5. Awesome. Thank you, Steve. Cool. Well, we got a few people in here, it looks like. Hopefully the sound's a little bit better. And I do have to be honest, tonight I am kind of using you guys as a little bit of an experiment and trying a few things out. So I'll talk about that here in a minute, but welcome to my stream. This is the Grafted Branch Homestead, and I am Matt, and this is our special Saturday night live stream where tonight I am talking about solar systems, power systems, specifically 12-volt systems. And tonight, my goal is at the end of the stream to do a DIY, to build a small 12-volt solar system to power some lights and other small things like that. And my thought on it tonight, because it is such a wide subject, you could do it for really anything, is making one that would like a quail hutch or chicken coop or a barn or a shed or something like that. So we're going to end up doing that. I hope to give a whole lot of maybe theory and math and how things work and a little bit of that, so that way you guys can tailor it to what you need. So I do have a little bit of, I guess, disclaimer here. I think that was, let me see here. One sec. There we go. All right. And I did that on purpose there. So yeah, tonight we're talking about voltage and 12 volts and power systems and all of that. And I wanted to get caught up on my slideshow there. So that's why I got up here to the disclaimer and jargon and all of that. So let me give you a little bit of jargon for just a moment. First of all, disclaimer, I am not an expert or professional. Make sure you do your own research. As always, look into what you're doing and your specific needs. Make sure you're doing everything safely, especially with dealing with electricity. It is dangerous. You could get hurt, even though it's only a 12-volt system. That hurts. Your car is a 12-volt system, and I don't know if you've ever shocked yourself or seen someone shock themselves. It's not fun. So be very careful in whatever you do, and especially in the DIY we get into tonight. I'll mention that a few more times. Other than that, kind of like I was telling you, tonight is a little bit of an experiment. Talking about power systems or solar systems or anything like that is such a wide subject. I think it's really best done when broken down and then put together. So doing a whole video maybe on the battery or the solar panels or different things like that. Or really, to be honest, it's best done in a video where I can zoom in on certain components, slow down, edit, and really give it the full attention it deserves. I decided tonight to do it in a live stream. One, I'm pretty nervous about doing this. I love I love working with power systems and electric systems and solar in particular, or other, but I think it's a ton of fun. It's a big hobby of mine, and I can do it. I think I can do it well. And then explaining that and teaching that is a whole nother animal. It is such a wide, there's so many applications and ways you can do it, and what you want to tailor it to, that being able in a live stream to touch on all that really isn't going to be possible. So tonight, I'm going to give you guys my best shot at it. I have a slideshow. That's what I was trying to catch up to hopefully help kind of keep me on topic, especially because my mind does wander so much and I forget where I'm going with things and stuff like that. This was a particular task that was pretty daunting to me to take on and show people how to do solar. So I'm going to give it to you in the live tonight, kind of feel out how people do with it, or how I explain stuff, and then build that system. And then we're going to revisit this in June. June is solar month here on the homestead, both in the homestead herbal corner and in the other videos we do. So we're going to put out a lot more solar videos and teaching ones in June. So I'm going to take tonight's and gather this together and be working on that for that. So whoop, lot said, there we go. And a couple people in here. Let me just say hi real quick. We got Steve. We got, looks like Aaron, Buster, CDB, Verna, Rustic Roots. A bunch of you on here, 10 of you. I may have missed a few people, but welcome everyone. Ooh. See if I missed anyone. Okay, cool. So let me pause for just a minute. So I'm not sure exactly how tonight's stream's going to go or how long it's going to go. The approach I'm going to take to it is, a little bit more of my jargon. I'm sorry. I wanted to say this. Let's see. Oh, okay. So a lot of terminology that sometimes people, I kind of have it on my board back here a little bit. I want to explain really quick, and that is solar system or solar generator. It's truly not a system or a solar generator. You're not creating power. You're really gathering power, or it's a solar charged system. So people don't like some of those terms. Those are ones I'm going to use, though, just for the simplicity of it. I did want to say I may mention theory, new technologies, efficiencies, or some different components, but this is in no way an all-encompassing. All-encompassing live, and just for the sake of time, I'm going to try and be sticking to driving or pulling back everything to that small 12-volt solar system we're going to build. My plan and goal is tonight to build this system, to teach a little bit, to give the math and theory so you can do it yourself. Many people know much more than I do, and you may be in chat, you may know a lot more than I do, or watching the video later. So I welcome constructive criticism. I deal with it very well. Feel free to leave it in the chat, or corrections or things like that, or comments, things you see, any questions you may have, or concerns, stuff like that. If someone has a question and you have an answer, feel free to drop that in chat as well. Hey, Nick, good to see you. Nick's here with Arizona. So Nick, we're doing a little different stream tonight on a 12-volt solar system. So I know Nick has some cool videos too on builds he's been working on lately. Oh, and you'll have to go check those out. But let me not get too sidetracked. And so I have my slideshow tonight to help keep me on track. And what we're going to do is we're going to go through a little bit of terminology that's involved around solar systems or electric systems. So when we hop into that, really what we're doing by building a solar system is we are moving power from one place to another to be used. So whether that be from a battery to a component, or we're gathering it from something like the sun or the wind or water, and we're storing that in a battery. We're moving and storing power, and we're doing that through wires and different various components. So with that, one of the biggest things that you're going to look at, and so I'm going to use a couple different analogies tonight so as to maybe break it down so you can understand it a little bit better. A lot of it's going to focus around the wire, because a wire is a not device, it's a thing that it has an insulator and then a core, and that core is meant to transmit electricity from one thing to another, and so that way you can use it to do something, to do a light, to do a motor or a fan or something like that. Whether you're doing it so that you can use it to help assist you with something, or maybe be automation or different things like that. There's many reasons, and we'll get into why you would want to build a system in a minute here. But it's going to kind of revolve around a wire. A wire is a lot like a garden hose. And so we'll be getting into that analogy, and I'll use it quite a bit. So that's why I mention it a lot. but a garden hose transmits water throughout the line from one place to another. A wire does the same thing. So I'm going to hop into my slideshow real quick for a minute. Love it, Matt. I'm working on fixing your 12-volt alternator. Oh, on your 1987 GMC 4x4 tonight. How cool. Very cool project. And actually, that's cool you said that, because I did want to mention, when you're talking about solar systems, and I'll talk more about it, there's different voltage you may want to do. And I'll hop into that. But to briefly touch on it, there's 12 volt, 24 volt, 48. I'm using a 12 volt tonight. That is what I use most, and a lot of outside and for the projects I do. It's really convenient because your car runs on a 12 volt system. So finding parts for it is really easy, and doing stuff like that. I actually also have up here on my board. And so this is another reason why doing this talk is hard in a live stream. I'm trying to fix that tonight by using cameras and things. But I got my board up here. Oh, you can't see the bottom. That's it. On the bottom, it says, here's the little bit of preparedness tip for my stream. If you have a car, you have a 12 volt generator. You have a generator. And so your car works on a 12 volt system. It is powered by gasoline that runs that engine and an alternator and charges up your battery. Your car's electric system is a 12 volt system for the lights and starter and things like that. So I like it. It's easy to find parts, in particular things like lights and stuff like that. Finding waterproof ones and stuff is good. Mr. Landfill, things to watch out for when looking for lighting to use with solar. Lanterns that use 8 batteries are most likely 12 volts and become modified to be run on solar. Yes. So in a bit here, we'll talk about series and parallel and how you wire things together. And when you look at how they put AA's, either how they're wired when they're kind of like that, or if they're end to end in a flashlight, your AA battery is 1.5 volts. So if you have 2 of them and they're end to end like that, then you have 3 volts. If you have 4 of them, you have 6 volts. If you have 8 of them, you have 12 volts. So we'll dig into that. And actually, before I get ahead of myself, let's go ahead and start. A converter. Inverters. Converters and inverters, and I'll talk about that too a little bit. Here, look. Ta-da! So in today's build, we're not going to use well, let me get to this. In today's small 12 volt build to power fan, a light, a little actuator, things like that, particularly for like a coupe or hutch or something, I'm not going to use the inverter, but I am going to talk about it and how to do it. At the very end of my stream, if I have the time and I want to, I'm going to tinker with putting together my bigger system, and that does have a inverter, and I may use that. So let me go ahead and remove these real quick and get to my video real fast. Otherwise, I'm going to end up just chatting all night and I'll never get to it. I told my wife, I don't know if this is going to take an hour or 2. So by the way, if people do need to leave, feel free to watch later and catch up. I am going to repost it in a video, hopefully. All right, let's get to it. Supposed to pause. Okay. So let me pop up here real quick, and I'm going to chat for a second, then I'll stand up and I'm going to write some stuff on the board, and you can join me up there. But the first thing you need, excuse me, my voice cracked. The very first thing when you're looking at building a power system, an off-grid system, solar-powered, wind-powered, water-powered system, whatever it may be, is you kind of need to get an idea, at least, of what are you doing it for? What's the purpose of the system? Is this system going to be in the shed for lighting? Is it going to be on a quail hutch so they get their 14 hours of continual light, in which case it comes on with a timer? Is it going to be in lights out and around your yard or coop that maybe come on with photocells with the sun goes down, or with motion detectors when someone comes by? Is it a system? Are you planning on using it for a large system within an inverter, maybe to power things like a off-grid system or a freezer, some lights inside? Are you looking at wanting to have that 120-volt power where you could plug in a cord of your laptop or something like that? Is it lighting in a barn that you want to be able to walk in and flip a switch and turn it on? Um, or is it maybe power just so you can power some tools? You can move a shop vac out or something like that. So I have a bunch of stuff up here and around me, and I'll be moving it around and talking about it through the night. Some of it relates directly to the 12-volt solar system, some not, but I will talk about it. So one of those things I have up here is my solar generator, or it's a battery system that you can plug things into and use that can also have a solar panel plugged into it to charge it. Here's a solar generator. This is great if I'm just moving it outside and I need to plug in tools or a shop vac or do different things like that. Maybe you have this set aside just for emergencies to power some lights or a small fridge or something like that for a couple hours in case of a blackout or brownout. If that's what you're looking for, this may be your option. This may be something to go for. These are getting a lot better and can be great and actually used as your entire solar system if you would like. You can plug DC volts in, and we'll get into that in a minute, in them, and kind of make a custom system. But one of the downfalls is this is more so going to be like I'm plugging in a bunch of 120 volt plugs to it, and then the solar panels. These can also kind of get pricey. So in this case, the solar system we're building today, the very small one, is going to be used in a shed for my son, his shed outside, that he can use it. So this will be his solar system. So it's going to be a really small one. It's just going to need a light he can flip on and off, and then a fan that runs occasionally. The system I'm building is going to be very similar to the exact same one that's on my on my new Silky house right now. And so we'll talk about it and its capabilities. I'm going to get into what things can do and all that as well. If you do have questions, feel free to drop those here. Camping stores and truck stops have a great selection of items that run on 12 volt. Yep. And that's why I'm using that. So let me go ahead and hop into the video. The video is going to give you first a little bit of terminology and some things we're looking for. And I'm going to keep stopping it, but let me go ahead and play here. Oops, I meant to pause it. Okay, I'm going to pause it here. So you'll hear me go back to the water hose or the water and analogy quite a bit, because it's quite a bit like an electrical system. So what I have here is the first thing we're talking about is our electric system. We have different components. You're going to have your current, you're going to have your voltage, you're going to have your amps, your watts, and all these different things. So I think I got ahead of myself, or I wasn't paying attention. This is part of why doing it live is a little bit hard, but or maybe I just didn't do it yet. So yeah, let me. I may jump around a little bit, but yeah, electricity and current's a lot like a garden hose. So the current or the electricity is a lot like the water flowing through the hose. That can be done at different pressures. You can have a really big hose at a low pressure and a really small hose at a high pressure, and have those filling up buckets and end up filling up the bucket at the same time. The small hose with the high pressure would fill up the bucket with the same volume as the big hose with the lower pressure. Oops. Trying to remember how I did my video. Oh, okay. Here we go. I'm trying to remember what I was going to talk about when I made the video. So yes, AC and DC. If you have a wire and you have two wires, you're able to push current through it. Now, current travels in two different means, either in AC current or DC current, either in alternating current or direct current. In our 12-volt system here, we're going to be using direct current. When you're adding something like an inverter, you're adding alternating current. Your house is on alternating current. So direct current, it's easiest, I think, to think about it like a river. So direct current is moving like a river. The water, the current is physically moving, and it's all pushing. And that's moving in a direction. So direct current is like a river. It's moving in a certain direction and is creating a loop in your system. And then alternating current is best to think of as like a wave, whereas the whole body of water itself is not moving, but the force is moving across it. So I'm going to stand up and hop up here to my board for just a minute and draw a little diagram of that. So hopefully you're not just looking at my butt on camera. But I'm going to leave that one on because that's what the mic is on. So let's see how this is going to work out. All right, let me hop up here real quick. Erase what I had written. And this is important because when you're looking at different components, you need to make sure they're direct current. You can't run alternating current on direct current systems. Solar panels and a lot of your batteries, all of that is going to be direct current. So when you're dealing with it, it's important to know what direct current is and how you're going to deal with that, and then alternating current as well. So let me explain it here a little bit. That might be a little easier. So when you have your wire, here we go, direct current. You have your wire, you're going to have your flow of electrons. And these in direct current flows like a river. So those are going from the wire. So you'll have your red wire, you'll have your black wire, and here maybe we have a light. Direct, and here's the battery. And so what this is doing is this is creating a loop. It's flowing through here, coming through the light, back through, and to the battery. And so you're creating a loop or a system. Whereas alternating, so I'm not an artist at all, I'm sorry for my drawings. Whereas alternating current, here's your wire, doesn't actually flow or move. It almost vibrates, and it's not truly vibrating, it's oscillating is the word we use. So what that's doing is it's going from, here's your positive, here's your negative. It's going from positive to negative like a wave, and it's moving very, very quickly across there. So quick that it's able to transmit those electrons or those powers across the wire in an oscillating format. So in a direct current system, let me sit down real quick. The reason I say that is because in a direct current system, your positive and your negative are going to be very important. You're going to want to make sure you pay very close attention to that, and that's the system we're using. In some things, the positive and negative, like lights and stuff, if you get them reversed, won't work at all because you're not creating that system. Some things it will, such as with an actuator. In an actuator, if you run the current, you're red to red, black to black. Sorry, my nose is itching. It's going to open. It's going to turn on, and it's going to pull the actuator out. When I flip it and I put red to black and black to red, so it's flipping the polarity there, it's going to pull in. And I'll get to that when we talk about accessories a little bit. But that's why direct current is important. Whereas alternating current doesn't necessarily matter as much which way it's plugged in or which of those two wires are. And this is why, for example, I don't know if you've ever wondered why it is that you can take your cell phone charger and you can flip it around either way and plug it in the outlet and it works just fine. And there's a lot of things you can do like that with 120 volt cords. You can flip it in either way in the outlet and it works just fine. And there's some you can't. And like certain motors or heat elements or things like that, they need it in the certain direction. So you'd plug it in, but that's why. Hopefully that makes sense. Does that make sense to anyone? Sorry, I'm getting nervous. I get all itchy. I try not to itch. Hopefully I don't lose everyone. Okay, let's get on to it. Okay, volts. This is one of the first things you're going to hear or you're going to deal with in the system. So volts here, and I had the video of the hose again. Volts is best thought of or imagined as the pressure going through the hose. So a 12 volt system is a certain pressure going through that hose, and a 24 volt system is a higher pressure going through that hose. So volts is best thought of. Sorry, I'm really trying not to itch. I get nervous, I get all itchy. And maybe I'll step off camera and itch real quick. But anyways, so that's going to be volts is best thought of as the pressure running through the line. I put here compatible because volts is also a good way to look at if your system components are compatible with themselves. This is how you'll see everything. So a 12 volt battery, a 12 volt light, a 12 volt motor or fan, or it'll be 24 volt, maybe solar charge controller. And this is the compatibility. So you're not going to want to put 24 volt parts with 12 volt components or vice versa. You're going to want to make sure they match up. So volts is good and for two things, or looked at, I guess, two different ways, is as the pressure going through the system and then as the compatibility of it. One of the next terms or things you'll hear quite a bit is amps. And I think amps is best visualized as the water tank, the volume of the water in the tank. So amps, think of it as the volume of the water in the tank, and then that pressure that comes out the valve is the volts. So your amps in a battery is going to be how much power that battery holds, the capacity that it can discharge. And the voltage is going to be the pressure at which it does it. So this particular battery I have right here, this is a 12 volt battery and a 35 amp hours. So the amps in this battery, or the capacity it has, is 35 amps. So you can run 35 amps for 1 hour before you deplete this battery. Now that's not completely true because this is a flooded lead acid battery and you can't discharge that all the way. I'll talk about that more. But in theory, 35 amps, and the volts is the pressure that's coming out. If this was a 24 volt battery at 35 amps, it still has 35 amps that it can discharge that you can use, but now you can use that at a much higher pressure. If that makes any sense. Okay, so here I put a rain barrel, and this is because maybe a rain barrel analogy is a good way to think about it. And so you have a rain barrel, and that's filling up with water, and that's your amps, that's building up. And then you open the valve on the bottom, and that's going to let out a certain pressure, say 12 volts. If I want that higher, I can add a water pump or a tank or something like that to create a higher pressure. And think of that as 24 volts coming out. Next term you're going to hear is watts. A lot of times you'll hear 100 watt, like on a solar panel or something. Watts is really, let me pause real quick. Watts is really just a answer, if you will. All watts is your volts times your amps. And when you find the watts, this allows you to figure things out, like how much amps or how much capacity a battery has, and what different things you can run. Hey Andy, good to see you. So here I have a couple little things. It also, oh, here we go. In addition to that, it also allows you to be able to figure out other parts in a thing. So let's say I have a component, a light or something, or a solar panel, and I know the watts and volts, but I don't know its amperage, or I know it's volts and amps, but I don't know its watts. I can use this equation here, and volts times amps equals watts, to figure that out. So I'm going to go to my board real quick. And I'm sorry if I'm not explaining this very well. I do think a video would be better, but that's okay. When I actually get to building the system, maybe that might be a little more enjoyable. But let me go ahead and do this real quick. And this is important because this is what you're going to need to know how big you're going to need to build your system. So we talked a little bit about why you're going to build your system. And so I decided this is going to go in a shed, or like the silky house or something like that. So it's going to be a small one. It's going to need lights that are on timers for automation, as well as maybe just a switch so I can turn things on and off. And so with my small system here, it's going to be running on amps and volts, just like any of them, and then the watts. And so, for example, to figure this out, I'm going to use this battery again. And so we know it's 12 volts and 35 amps, but I don't know the watts. So what I can do is do the volts times the amps, 12 volts times 35 amp hours, right? And that's going to give me its watts. So 12 times 35 is 420, I think. Right? And so that's going to give me watt hours. And so watts to watt hours, the difference there is just time, obviously. And so what this is going to tell me is that this battery here, its capacity is 420 watts. Now, it is flooded lead acid, like I said, so you can't discharge it, or don't want to, below 50%. But just for the sake of simplicity in math, well, you know what? No, maybe we want to do that. So this particular battery is flooded lead acid. And so when I talk about batteries, I'll talk about different ones. But this one, you don't want to discharge below 50%. So I'm going to divide it by 50. Hopefully I'm not confusing things. And so that's going to give me 210 watt hours that this battery can use. Now, I'm probably jumping ahead on my little thing, but I have a little light here. You can see this little 12-volt light. And I happen to know when I bought it, this light is 1.2 watts and 12 volts. Again, it's 12 volts, so compatibility with the battery, awesome, all 12-volt system. And I want to figure out the amps. I have the watts and volts, so I can do 1.2 watt on this light, and that equals our volts. So our 12 volt times blank to get our amps, right? So then we would want to do, see, this is where the live, I'm going to get myself confused. Okay, let's see. Let me think. So we want to divide it. So we would want to do 12 divided by 1.2, right? Can I have my calculator? Geez. All right, someone do it for me. This is the part that makes me nervous about doing it in a live stream. All right, because then I get myself confused with all the numbers. Okay, well, let's do it this way. We could figure that out, but I'm gonna get myself confused. Anyways, you can see how you can use the formula if you know two of them to figure out the third. What I can do here though, because with this particular light, I already know it's gonna take 1.2 watts. So this light will take 1.2. So the battery use that I can get out of it to drain it to 15 to 50% is 210 watts. And so we're going to use 1.2 watt on this particular light. And so that can run for what, like 18 hours or something like that before it drains this battery without any solar input. Okay, I confused myself a little bit there, but hopefully that made some sense. Okay, cool, thanks. Appreciate that. See, I need you all to help in. Okay, so 12, so it's going to be 0.1 on the amps. And so 35, and that's not right. All right. Yeah, I may have messed myself up on my math a little bit there. But amps times volts equals watts, and they'll give you watt hours. And what you can use it is to figure out how many watt hours you have and how many a particular device or a load is going to take. So if I have 4 of those lights, here, let's just do this for simplicity so I don't get myself all tripped up. We're going to use our 100 amp hour 12 volt battery. That's going to be like this big one here. That's going to be your kind of base that you start with. So if we have a 12 volt 100 amp hour battery here, we are going to get our watt. So 12 times 100 for our volts times amps, and that's going to give us 1200 watts. 1200 watts or watt hours. And so then if we have this device that takes 1.2 watt on this little light, and let's say we have a couple lights that take 1 watt each for the simplicity of it. So let's say we have 4 lights at 1 watt each. So we have 4 watt hours. So it's going to take 4 watts in an hour, and divide that. And so then that would give you how long that could run. Okay, cool. Hopefully that's a little bit better. Let me hop into my video a little bit because I'm just going to trip myself up. Thanks, Mr. Landfill. Oops. Okay, yeah, so there I'm just saying your lead acid batteries. Okay, here we go. So here's a couple other terms. Pause. And this is in case there are certain components in the system that you can change the voltage and the amperage of, and that would be by how you wire them in. A lot of times, well, this is done with the batteries and solar panels. Very rarely in a system, unless you're doing a very, very small one like we're doing tonight, are you just going to have one solar panel and one battery. A lot of times you can have several batteries or several solar panels most of the time. When you have several batteries, it's called a battery bank. When you have several solar panels, it's called an array. There's a couple ways you can wire this. If you want to keep your system all at 12 volts, then what you're going to want to do is wire it in parallel. There's 2 different ways you can wire solar panels and batteries together, join them together, and that is in parallel and series. If you want to keep the voltage the same, then much like on the diagram here, you're going to want to wire them in parallel. So you can see here what is done is the positives are connected together and the negatives are connected together. When these 2 batteries are connected in parallel like that, they stay 12 volts. That does not change. What changes is the capacity in the battery. So now instead of being 100 amp hours each, like in the diagram here, you're going to have a 12 volt 200 amp hour battery. So it's still going to run at that same pressure at 12 volts, but now you have 200 amp hours to use. And 200 amp hours at 12 volts is going to give you what? 12 times 200, 2400. Yeah, so 2400 watt hours to work with. So quite a bit more. That little 1.2 watt light, or the four little 4 watt lights, could run on a 2400 watt for quite a while. There are things that take quite a bit more. So when you get into heating elements or motors, things like coffee makers can take like 1500 watts. So that 2400 watt system that we're showing here in the diagram would be able to run a coffee maker for like an hour and a half, maybe, or something like that. And that's with 2 of these 100 watt batteries on the 12 volt system. Okay. These are solar panels, again, in the same. So solar panels, you would want to wire them if you're doing all 12 volt system. You want to wire them to be all 12 volt as well. Your voltage on your solar panels needs to match what the voltage in the battery is, for the most part. So that's what that needs to do. So solar panels, you'll wire the same way, either in parallel or series. So in parallel, the positives go together and the negatives go together, and you run it just like that. That's going to keep it in 12 volts. But instead of this 100 watt solar panel, if you put 2 or 4, like in the diagram here, that's going to give you 400 watts still at 12 volts. Okay, if you're wiring in series, the reason you do this is if you need to step up the voltage. There's several reasons you would want to do that. Run a 48 volt or 24 volt or 48 volt system. If you're powering bigger things like your house, or you're looking for an off-grid system, much bigger appliances and components, stepping up the voltage is a good idea, running like a 48 volt system. By doing that, you're going to step up the volts, and you're going to decrease the amperage that's needed to run through the wires a little bit. So wires are very expensive. The reason you would do that is you don't need quite as big of wires when you're stepping it up like that. Yeah, so the other way you can wire is in series. And by doing this is you'd wire each battery, all the positives together, and then, or I'm sorry, you'd daisy chain it. So you'd run the positive to the negative and the positive to the negative, and you would do that on all the batteries. So you're daisy chaining them together. This is going to keep the amps the same on the battery, but increase the voltage. So on a 100 amp hour battery, if you put 2 of them together and they're both 12 volt, and you wire them in series, you're now going to have a 24 volt system, but still have 100 amp hours. You don't get 200 amp hours out of that because you're increasing the volts, not the amps. And there's the solar panels are done the same way. And I am going to kind of fly through this a little bit more. It's a little hard to explain. I think in the live especially, I think this would be much better done in a video. So we're almost done to the end of the terminology and that type of stuff. And then I'm going to look at questions a little bit, and then I'm going to go through and show all the different components, and then just go right into building our system, getting into the more meat of it. So just sit tight for another minute. Look at that. There we are. So solar system components. These are not all of the components in our system. However, these are the ones we're going to be using, and a majority of them. Okay. So first of all, excuse me, jeez. First of all, I put these somewhat in order of how I think you need to look at them when you're figuring out or designing your system. And that would be your load or your devices. So one of the first things I think you should look at is what you plan on powering. And this has to do again with why you're building the system. Are you planning on having large load. Do you need a inverter? Are you powering larger motors or components? Is your load smaller? Are you planning on just doing lights and things like that? Some 12-volt lights, or do they need to be 100-watt, or different things like that? So what load and devices are you going to be using? So I have on this table here. Oh, I'm going to hop into it. Wait. Next, we're going to talk about batteries, and then solar panels, or your input, whatever that may be, charge controllers, wiring, fuses, switches, or a means to control it, right? And then also meters, chargers, tools, and other things. Okay, yeah. So very first, system components. What are you powering? The compatibility, and does it need an inverter? And so let's go ahead and take a look over here. Can I make that bigger? Nope, I make me bigger. I don't know. Okay, that's all right. So on this table, I have scattered out various things that I would be using in my small 12-volt systems, plus some other things as well on here. And so I'll show a couple of those. Some various things I use is things like this. So this here is an actuator. This is a large motor. This does draw quite a bit of power. So it's a 12-volt linear actuator. It doesn't give me what either the watt or the amp is. So this, I might need to use a meter or something like that to determine that. I can tell you things like motors and heating elements take quite a bit. However, with this actuator, it's not going to be running all the time like a light would. It just comes on and off for a minute here and there. So this particular one is a very large one, quite a bit larger than I need in my systems. This is one I use to control the door, like in the chicken coop that goes up and down. What I'm going to use this particular one for here in a project coming up is to raise and lower their feed so that the rodents can't get into it. And so that's a project coming up, but this is something you may want to use. This is 12 volt again, so it's compatible. It plugs in without needing any extras. Some of the other things I have is 12-volt fans. Little computer fans can move quite a bit of air and work out good, especially on small systems. And so we'll have fans. Like I was showing, my favorite lights are to use this. This is a license plate light for a vehicle. They're waterproof. You can get them really cheap and anywhere. They provide a lot of light, and they're pretty low voltage. So this one here is the 1.2 watt 12 volt or low wattage. Your mini appliance products run on low watts. Waffle makers, that's awesome. Yeah, egg cooker, grills, and noodle cookers. They may not be great for a large family. And there are components you can get, like you can get split AC systems and things like that that run a lot better. They're made, or fridges or freezers that are made to run on these systems. So what I'm saying is kind of just in general, there are exceptions to everything in here, but yeah. Let's see, here's another little motor. This little motor is meant to go on an auger, and that will turn the feed that will come out of and feed the silkies on their coop. We have here a little water pump. So I use two different types of water pumps. This is one I think I'm going to be using from now on. I do a lot of redundancies in my system. So my solar systems, and this is again one of the things you need to look at when you're developing yours and what you want it for. Is it a very large central system that powers everything, or a lot like I do? I like the decentralized system. So I'll have a lot of multiple smaller systems. I have one bigger one, like right now, that's the Quail Shack, that can power the others if I need. Oops. So here I have a switchover switch or a cutoff switch. I can use this to turn power off on one system and on another. So I can have multiple systems and use backups and things like that. But with that, I have these little water pumps. These are good if you're not moving the water for a very long distance. I also use fuel pumps, 12-volt car fuel pumps to move water. Those work out great. They do take quite a bit of power, but again, they only come on and off briefly. A couple other lights. I like some colored lights. I got a green light. I have these little red lights I like to use in the coops before and after the main lights go on and off. What else do I have here? Some other things we'll get to, switches and stuff like that. And of course, here I have a 600 watt inverter. This will work good on our 100 amp hour 12 volt systems pretty well. 600 watts will power my freezer behind me or something like that just fine, and do pretty good. Now this 600 watt inverter, I know it's 12 volts and 600 watts. So that means it's going to be what, like you could figure out the amperage on it and how much it's going to take and pull out of the battery. It is going to use a little bit of residual power as well. Here is the big boy, and I have this sitting out because this is something I want to mention when you're building your systems. So right here I have a 3,000 watt 12 volt inverter. This is a 3 kilowatt inverter. This will power a lot of things. It will power heating elements. It will power the toaster and fridges and all that good stuff. This is something I'm not sure I should have bought. And I'll explain why a little bit. It is 12 volt. When you're doing a whole house or you're powering a lot of things, because of the wire size you use, the heat it puts off and stuff like that, stepping up into like a 24 or 48 volt system is a better idea. Now, this is not a loss at all. It's going to require a much larger battery bank and stuff like that. Now, I'm not going to be running it at 3,000 watts all the time. I can have this plugged in and just have a couple hundred watts plugged into it and not drain it all the way out. These are things that would probably need their own video to really deep dive into. But I do have a few of those. So the reason you would use an inverter is if you're going from 12 volt components and stuff like that, and now you want to plug something in that's 120 volt, like your laptop or something like that, a fridge or freezer. That's when you would move to an inverter. O2 Cool makes a camp fan that runs on 8D batteries and already has a 12 volt port. No need to modify. Oh, hey, how cool. I'll have to take a look at that. Hey, Palmetto Paratrooper, shalom. Good to see you. Okay, so let me keep moving on a little bit. So we talked about components. So the first thing when you're looking to build your system is what do you need it to do? And that's going to give you a good idea. So I may know I'm going to need, for example, 4 of those 1 watt lights in the coop. So that's 4 watts there. I'm going to need an actuator maybe that runs at 5 watts, for example, and a fan that runs at 3. So I can figure out all that watt hours and how big of a battery I'm going to need. Okay, so the next thing I'm going to talk about, you figured out kind of what you want to do with your system and the devices basically that you want to run off of it. And now you're going to need to power it. So I put batteries or not. And I have that because if you're doing a solar system, some of them don't necessarily require a battery. Some things that maybe just run when the sun's up, like some people may have a pond fountain that's connected to a solar panel. So it's a solar system, it's solar fed, but it doesn't need a battery or anything else. That solar panel may be directly connected to that pond fountain, so when the sun hits it, it comes on. Another place you may use this is on a, I can't think of the name right now, a solar tracker. So a device you use to move your solar panels automatically to track the sun. On those, a lot of times an easy way, at least an easy way you can build those, is by using a motor directly connected to small solar panels that when the sun hits them, it moves the motor to make it simple, it moves the motor in a direction so that it puts the panel in the sun, and then the main panel in the sun, and the small panels are now shaded because the main panel's in the sun, and so it stops that motor. I don't know if that made sense. But there are times you may not need batteries. Batteries, though, are primarily what the system is going to run on. So it is a solar collected, solar gathered system, but it's really the power systems run off the battery. So there's a couple different kinds of batteries that you can pick from. There's a lot of different kinds. I'm just going to talk about two really here, but the main ones you're going to have, like the ones in your car or you come across, are going to be your flooded lead acid batteries. These are filled with water. They can be maintenance. They're good in low temperatures and high, a lot like your car can do. They do better outside than something like this bigger one here that's a lithium battery. However, the flooded lead acid batteries, you can only discharge them about 50%. They're a lot heavier and things like that. Whereas a lithium battery, you can theoretically discharge to 100%, and they don't necessarily do as well in temperature though, cold and stuff like that. And I'm not gonna go into batteries all the way, just kind of briefly touch on them. But there's a couple different batteries. So you're gonna want to choose which battery you want for your system, because this is gonna have to deal with the compatibility of your system. So in my really small one we're building today, we're using a flooded lead acid battery. I'm doing this because it's going to be outside. It will be somewhat insulated, so because they can freeze and not do good at all. So I will insulate the box it's in a little bit and vent it. But I've decided to use that because it's a smaller system. The lithium ones can have a little bit more cost to them and all. This is what I'm using. In the bigger system that I'm using inside, I'll be using lithium. And the lithium ion batteries need their own compatible components, such as the charge controller and your charger. All right, if you guys are just joining, once again, I was really nervous about doing this in a live. I think it's really hard for me to explain in a live. It'll be much better in a video. Kind of using you guys as a guinea pig a little bit too. Hopefully you're understanding them. When we actually get to building the system, maybe it'll make more sense. Okay. So the next component I put that you're going to want to look for. Oops. Oh, what did I do? Where am I at? Okay. Okay. So you have your devices that you want, whatever you want your system to do, lights, motors, whatnot. You have your battery. You've decided what type of battery you want. And because you know basically how many watt hours or how much amperage your devices, or a rough estimate, your devices are going to pull, and usually add a little bit to that, you'll know what size battery you need. And I can write all that out in the video. I'll do that, but I can do that. And then solar panels. So solar panels are going to be your next thing. Thank you very much. Solar panels are going to be the next thing. And this is going to be your means of gathering the power or the energy. That's done in many different ways. It can be done through wind, through water, through difference in temperature, through gravity. There's a lot of different means, kinetic means. There's a lot of different ways you can collect energy. Today, we're talking about solar panels. Now, these are PV solar panels, which means photovoltaic. And so what they do is they take the photons from the sun and they hit the solar panel, and they're able to take that and convert that to power. The way they do that is the solar panel has two silicon layers. And so when the photons from the sun hit those layers, to make it simple, they basically punch a hole and separate an electron that then move to either end of those strips in a positive and a negative. And so what you're getting is trying to think of how to say it simply. You're getting the electrons are coming from the photons. They're hitting the solar panel, and they're moving on that to little metal fingers that are out on it, and that's converted to the electricity. Hopefully I said that well. There's a couple different types of solar panels. You're going to have your monocrystalline and your polycrystalline. The monocrystalline are going to be ones kind of like this. They look black. They're going to be very rigid. A lot of times these are more efficient. They can collect more of the sunlight. Other ones you're going to have are going to be your poly. And those ones are going to, a lot of times they look blue. They can be flexible. They're not quite as efficient, but they're flexible. And those are good on things like maybe van builds or stuff like that. Whereas this isn't flexible. This is going to be better on a stationary build. Solar panels as well are going to be rated a lot like your battery. So they're going to be in 12 volt, 24 volt. You can change that by wiring them in parallel or series. But you're going to want to make sure they're compatible with your entire system. So if you're doing a 12 volt battery or a 12 volt battery bank, you're going to want to make sure you have your solar panel or your solar array in 12 volts. In 12 volts as well. Oh well, that was my 6-volt solar panel that's used to control one of the doors. I was going to show it, but it's down there now. So solar panels. Okay, so you have your solar panel that's going to provide power to your battery that's going to provide power to your lights and things like that. Now we need a in-between step a little bit. If we're just doing that, the solar panel collects energy at variable rates and will feed it into the battery. And it's not smart. It doesn't know when to stop doing so. As long as out in ideal conditions, it will continue to feed power into the battery, which can cause the battery to explode or do other bad things. So we're going to need a in-between component. This one here is a solar charge controller. This is a 40 amp. This is a little bit larger one. It's one that will be used on the lithium battery. Now this one, it's a little bit more expensive. It can do several things. It can run 12 volt, 24 volt, or I believe 48 volt as well. Nope, just 12 and 24. And then it can also do different types of batteries. So you can do your flooded acid batteries, your lithium ion batteries, your gel cell batteries, or different things like that. Whereas this, where is it at? Whereas this one, this solar charge controller, mic is muted. No, I'm not muted. Okay, so whereas this solar charge controller is a little bit smaller, this one's 12 volts only, and it's only going to do the flooded lead acid battery. It's very specific. It works just fine, especially in smaller systems. Some people don't like them. I like them. I think they work great, and I haven't had issues with them. This one here is quite a bit cheaper, obviously, and it's very specific to our system, compatible. So 12 volt. And what this is this is going to take your power from your solar panel, and it's going to regulate it. It's going to make sure that the voltage stays regulated going into the battery and that it's not going to overload the battery. These also have some cool things a lot of times. This one has, so it has the full battery protect voltage set. These will also a lot of times have, like if you're, what this will do is if I'm using too much power, I'm drawing, instead of allowing my battery to go to 0%, which is not good for these batteries, it will stop it. It will cut it off. I can hit here, there's several different buttons. I can hit one here to turn the whole power on and off to the system. This one here also has that 5-volt USB, so I can plug a phone or something else into it. So the solar charge controller is going to regulate the power. Now, one thing I do want to mention, and I'll talk about when we're actually building, and this is going to be a long stream, I apologize. When we're actually building it, is the order you connect the panel and the battery to the charge controller is very, very, very important. You always want to make sure that your battery or the ability to to hold that power is connected to the solar charge controller before you connect the solar panel. So when you're connecting it together, you would connect the battery to the solar charge controller first, then the solar panel to the solar charge controller. And when you're disconnecting it, just the opposite. You disconnect the solar panel first and then the battery. Reason being is if this solar panel is producing power, as long as it's in the light and it's being hit by sun, it is producing power. It doesn't know not to. So if this is connected directly to the solar charge controller and there's no battery, it could fry out your charge controller. It's just going to feed power into it, and this has nowhere where to put it. Doesn't know what to do, so it can kill it. Okay. Let's get moving along. And I'm just kind of briefly skimming over this. We'll go more in depth later. Okay, and I can tell this is going to go very long, so I am going to cut out a lot of what I was going to say and just very briefly touch on this stuff. I'm going to go more in depth on videos in Solar June month, but I really, in this video, wanted to get to at least building the very small solar system, and that's going to take some time in itself. So, yeah, you may, if people do want to leave and come back and watch later, I completely understand. Or if you're just looking for the wiring. So let's go ahead and get to it. Oh, wiring. Okay, wiring is the next thing that's going to be extremely important. This is something that people overlook a lot, and you should not overlook. Wiring is important because it can cause fires, it can cause inefficiencies, or it can cause efficiencies. Wiring, you want to make sure that the gauge of the wire is appropriate for your system. So one of the ways we look at the thickness of the wire and stuff is you think of it as an amp rating. The more amps or the more volume you're pushing through those lines, you're going to need a bigger line. In a hose, it would be like a thicker hose, so you can push more volume through it. In a wire, it's going to be a thicker wire as well. There's different types of wires you can get. There's aluminum wires, there's aluminum core wires, and there's copper wires. Aluminum and aluminum core wires are much cheaper. Don't use them. They're going to cause you problems. When you're mixing metals like that, they expand at different heats and different temperatures and voltage and things like that. And one of the things you are always going to have with electricity is heat. And so being able to dissipate that is going to make for a more efficient system and a safer system. So one of the things when I first started building was I do want to tell this story just because, even though I'm trying to cut out time, is because of how important I think it is. So I've always been very curious with electrical systems. I've always taken them apart and breaking them down. One of the things when I first got a truck when I was 15 years old was I got a CB radio. And I didn't know, I learned by doing things. And at that time, the internet wasn't really around. So YouTubing stuff or Googling it wasn't really an option. And I wanted to wire the CB into the car. I didn't really know how to do it. What I ended up doing, to make a long story short, was I took a extension cord and I cut the ends off of it. And I cut a chunk out of it and I soldered a fuse in it. Now, the fuse wasn't even appropriate to what the system was. I didn't really know what I was doing. I took the end of those wires and stuck it in the back of the cigarette lighter and then into the CB. It worked fine. There was no fire, thankfully, or problems. It worked out really well, but I could have lit my truck on fire easily. The wire, I did not know what the wire was made of. I did not know the gauge of the wire, if it was appropriate for the current that it was holding, or if the fuse would have even popped if there was a problem. So I could have theoretically had a very big problem. So wiring, you want to make sure you're using the right gauge of wire. You want to use copper wire. Copper transmits the electricity the most efficient, and solid copper wire isn't going to expand and contract like a alloy or an aluminum core wire. So with heat going through the wire and electricity, it's going to expand and contract some. When you have the aluminum in the middle, it does it at different rates than the copper on the outside or just the copper. Aluminum expands more anyways, and that's going to create loose connections in your system over time. It can cause things not to work and cause bigger problems. So copper wire is more expensive, but stick to copper wire. One of the reasons people step up the voltage in the system is because by stepping up the voltage, you can run lower amps and you don't need quite as big of a wire. So with a small 12-volt system, we're not going to run into that too much. Okay, so I talked about wire, and then let me get on here. With transmitting electricity over length, you can lose some power. You can have some inefficiencies there. So the next thing I'm going to show you is a chart, and you can find this online just by Googling wire size chart. And so this chart is going to tell you the proper wire gauge you need for the amperage and the length. So let me play it, and then I'll explain a little bit. There we go. Okay, so here's our chart, and I got to look really close. So when I'm wiring my batteries in my Silky Coupe, I'm actually going to be using this battery here. This is a 12 amp, 12 volt, 12 amp hour, 12 volt battery. And I'm going to be using two of them in the system. So two 12 amp batteries is going to make for 24 amps. I'm keeping the voltage the same, remember, and I'm wiring them in parallel. So it's going to be 12 volts still, but now it's going to be 24 amps. So I need to know the appropriate size of wire to go from the battery to my charge controller. When you're using a 100 amp hour battery or bigger batteries, you could buy just battery cables. A lot of times these are going to be like 2 gauge or usually 2 gauge or 4 gauge. And you can buy those wires just for that. They are really big, really thick wires. And they're expensive as well. And so those are like these. And so one of the things you need to try and plan out well is your wiring. How much feet of it you're going to need, how far the battery is from the charge controller and the charge controller from the solar panel. Wiring can quickly become the most expensive part of your system if you're not careful, especially if you're buying wires and like this that you get the wrong size maybe. And so then you got to buy a whole nother wire. Now my wires from my solar panels to my charge controller, length is one of the things. So they are pretty thick as well. Let me see, these are 10 gauge. So here I can tell by my chart, a 10 gauge wire. So it should be able to transmit about 30 amps. So this here, in the solar panels, you can figure out how many amps. I can tell you this 100-watt one here is roughly 8 amps. So if I put 3 of them, well, we'll say roughly 9 to round up. We'll use 10 to make math easy. And you also want to overestimate so you're not running things how you shouldn't. So we'll say this is 10 amps at 100 watts, right? So if I put 3 solar panels together, that's 30 amps. So at 30 amps, I can do that on a 10 gauge wire. This wire here is 50 feet. So you can look at that too. It would fall within means. Now, 3 solar panels would be pushing this wire pretty much to its max. You wouldn't want to go over that. So that's where your wire gauge is going to come in handy in figuring all that out. Okay, hopefully that makes sense. And I think I talked about what I want to with wiring there. Oh, one of the other things too, so you're going to have your larger wire. I was saying this is a 24, so I am going to use a 10 gauge wire. By my chart here, I can use a 12 gauge wire to do my 24 amps. So this wire would be an OK gauge, not this battery, 2 of them. This wire would be an OK gauge to do that. And so when I do my project, whenever we get to it here in a few, this is the wire that will go from the battery to the solar charge controller. When you're doing something small that doesn't take hardly, just like an amp or something, I can use this smaller wire. And I forget, this is a 18. So 18 gauge. I can use this to power smaller devices. This one has the red and black both in a harness. These are really cool because they keep my wires nice and neat together, and it creates a harness. One thing I like to do is create wiring harnesses between my components. It's easy for maintaining systems and things like that. And when you build your system and you solder all the wires together and hide them in the walls or different things like that, you can have problems and end up having to tear it all apart. So I also use things like these connectors here. If you can see, it's just male and female connectors. I like to wire this into the wiring harness. We'll be doing this tonight. And so I can just connect and disconnect my different components. So there's a little bit on wires, and let's go ahead and run through here. Oh, bye, Verna. Have a blessed night. Anyone that leaves, I don't blame you. I'm going to continue talking until I get done with this. If you wish, come back and finish, or at least come back and watch the build. I'm going to do at least that build, even though it's going to be really late tonight, and then have to release in video. So, okay. All right. So we got our light. We got our battery, we got our solar panel, we got our solar charge controller, we got our wires between it. Now we need fuses. Fuses are different between AC and DC. The difference being is AC, because of its alternating current. Am I going to get this wrong? DC fuses need to be longer because the direct current can create an arc easier. It's a little more forceful, whereas alternating current fuses can be a little shorter. You cannot use an alternating current fuse in a DC system, but you can use a DC fuse in a AC system. Okay, we're only using DC fuses here, so that's not a problem. One of the things you're going to want to do is, before you run to your light or your motor or something like that, is put a fuse. One of the first places we do put a fuse is between the battery and the solar system. Fuses help protect your components and the wiring and all that. So a fuse basically is made just to break the connection if there's too much power going through there. So between the battery, if you had, for easy math, a 30 amp battery running into the solar charge controller, we're going to need a fuse that can handle 30 amps going between. So that way, if it overpowers, it protects your battery and everything. Now, you don't want to do it right. The math, right exact at 30. The math on it really is 1.25 above for the fuse. So if I was doing 30 amps, I'd want to times that by 1.25, and that's what the fuse should be. There's several different types of fuses. You can have inline fuses like this, fuses that connect directly to the battery, and those pop. Those are one-time use fuses. When they break, you have to reset them. Or you have fuses like this one, which is a manual reset. It just pops and I can push that down. So a fuse between the battery and the solar charge controller, and then fuses between the components like your light and the solar charge controller. So here, and I'm kind of trying to go quickly. I'm skipping over a lot of stuff I wanted to talk about, but I really just want to get to this build. So here I have a little box. This has several things. You can connect the power up top, and then the red or the power to the components on the side. On the bottom here is where the black or the negative would connect, and there's a negative bus bar where your negative wires will connect. We'll be using this in our build a little bit later here. So you want to make sure you have the correct size of fuse in your fuse box. Another thing I do want to mention here is, if you are using the incorrect wire size, but you have the correct fuse size, so like if the wire size, if you have a 10 amp fuse and wire that can only hold 8 amps, instead of the device, if there's a problem, clicking that fuse off, popping that fuse, and stopping it, your wire itself can become that fuse. And so it will heat up and light on fire, and you can have problems. So another reason you want to use proper wiring size. And I'm almost at the end of this little video. Okay. Okay, so now you have your whole system set up. You have the power feeding into the battery feeding power into your system, and you have your fuses, your solar charge controller. You got it all. Now you need a way to control it. So your light is just going to be on all the time if you plug it in here. You need a switch to make it go on and off, and there's several ways you can do that. First, there's a couple big switches that go on the system. I like to put these several places. This is just a main power on and off switch. So I put this between the battery and the solar charge controller, just on the other side of the fuse personally. So I turn the battery on and off, kill all the power to the system. I also like to put one of these personally between the solar panel and the solar charge controller. Not a lot of people do that, but I like it because if I need to work on the system, instead of having to disconnect the wiring from the solar panel so that way I can take off the battery, because you want to do it in that order, or different things like that, I can just switch off the solar panel and or the battery. So this is a good disconnect switch. The other switches or things you're going to use, so I have a switch here. This is just an on and off. This would be like your light switch. So if I want to walk in my shed or barn, I can flip the switch and turn the light on and off, or a motor on and off. So I don't have a switch up here. I had my up and down switch. So if you have like a chicken door and I want to make it go up or down, you can use switch like that. Let's see, I had a couple others. There's just this toggle switch. This is a photo sensor switch. So this would trip on or off with the light on or off with the sun or something like that. You can use motion detectors. My favorite to use is timers. And that's because my system, primarily, I'm doing it for automation to help me out. So with these little 12-volt timers, I can have power go in and click on and off and out, on and off on a timer. So I can set this to like 4 or 5 times a day to go on and off at different times I like. So my power will feed in from the solar charge controller. It'll go to the fuse panel, and then fuse panel to these little timers, and then out from the timer to the light. And I'll be using this in my build tonight. But to make this a little shorter, timer's just another means of a switch. So you have your whole system set up. You need to know what switches, timers, or things like that you need to control the system. Ta-da. All right, I think this is the last slide. Yep. Before we build. All right, so a couple other things in your build you're going to need, or components. This is going to be things like meters and stuff like that. So if I don't know how much power a device is drawing and I want to figure that out so I can know how big of a battery I need or things like that, there's different things you can do. So here I have a multimeter. This I can check, I can hook it up. I was going to show how, but I won't do that. I'll do that on a video. I can hook this up to my device or battery or whatever it may be and figure out volts and amps and things like that. On a 120 volt system, I have one kind of like this. So I can plug this in, and then plug my device in here like a freezer, and this will give me a readout on how many watts and amps and volts and all that it's drawing. So I can go ahead and throw those into my formula. Chargers. So I have a couple different chargers. Well, let me just grab this one because it's sitting right here. There's times you may need to charge your batteries for your solar system on days like maybe it's been really cloudy for a long time, or you've had an issue with your system that's drained the batteries completely. One way you can bring them back up is just turn any outgoing power off and leave the solar panels on there to charge that up. That might take a while depending on how big your array is. You may need to quickly charge it. You may want to do that off your house power or off a gas generator or something like that. So here is a charger, a battery charger. This one is used to charge the flooded lead acid batteries. And I have another one, this one here, is used to charge lithium batteries or different batteries. You need to make sure you're using the right charger to charge the battery, or you can have very big problems. A lithium battery operates very different than a flooded lead acid battery. So chargers, and then there's going to be some tools. I also did not really start off with tools when I started doing this, the proper tools. I would either use electrical tape, mostly, or solder if I was getting fancy, to connect my wires together. A lot of times they were just twisted together. Bad way to do it. They can come apart. You can cause fires. You can create inefficiencies. Having the proper tools and doing it with the proper tools is very important. I also, a lot of times, will just use a knife to cut the insulation off the wires. Make sure you get yourself a couple tools. So wire strippers. And then instead of soldering wires or just using electrical tape, you really want to get yourself a wire crimper. So a wire crimper cold fuses or cold welds your wires together, or your wires to your components. So if I'm going to put a wire and I'm going to attach it to my battery back here, the battery I'm going to be using in a minute for our build, I'm going to attach it with one of these little attachments or these little things. And so I'm going to take it and crimp it on the wire. And we will show all that in a moment. So wire crimper is a tool you should have. There's probably also various other tools that I'm not mentioning right now. But there we go. So my slide says let's build. That means I can take the slideshow off. Okay, let's see. And it's 9:30 my time. This is taking, I knew it was going to take a very long time, and I actually cut out about half of what I was going to say. So this definitely does need to be in a video. But now what I'm going to do is I'm going to pause for a quick second. If you guys need to grab yourself some coffee or something like that, do that just for a minute. I'm going to move these tapes, and I'm going to prepare myself to the cameras and all, so that way we can build this small system. And we're going to do that on camera. It's not going to be quite as formal. I'm just going to talk about what I'm doing, and then we'll probably say goodbye. And I'll work on putting this together in a video. So grab yourself a cup of coffee, do something like that if you want, while I move things around for just a moment. Okay. Okay, let's see. So I want to get it so that it's on film, and I am too. And we still got about 5 people. I am going to go turn on some water and start making a cup of coffee. You can still hear me when I was walking around. This is the grafted. So I had my grafted tea. I'm going to need some coffee, though, because I'm getting kind of tired. And I really do want to build this little system. So here, what I'm going to talk about real quick, the components that I'm going to be putting in. This isn't everything, but let's see. So this little system, and I skipped over some very important stuff I keep thinking about. Okay, that's okay. One thing I did skip over, though, that I just want to mention really quick is when I was talking about making windows like open and close, or doors go up and down, that requires in a DC system the voltage polarity being switched. And so the way I do that, and I can control that and make them go up and down by just using like one timer and stuff, is using relays. Relays are really cool because I can take a relay, and you can either have like a smaller voltage power, like a 5 volt, click it on or off, and output 12 volts to a device, or I can just do it all 12 volt. But that's something I want to mention. Okay, not allowed. No coffee. Oh, I didn't say anything bad. Okay, good. She's telling me no coffee. Okay, so first of all, we're going to build this little system. And like I said, I'm going to get water. Yes, we are going to get coffee. Give me a minute. You can probably still hear me. You going to join me, Solo? Okay, there we go. We'll get that water heating up. Get some flavor crystals going. Alert tea. So my alert tea, I'm out of my. You need to get down. So one of my problems with my teas is I want to be drinking them too, but we have a very limited supply of the herbs and the teas and things. Can still make a little bit more, and I still have more alert tea. I have some bags and things sitting there, and I have been so very tempted to open one and use it for myself, but then I have one less for the shop. And I'm already having a lot of trouble keeping stuff in the shop, which is a very good problem. Okay. But yeah, so that's why I'm not drinking alert tea. Otherwise, I would. I still had some of my harmony left. What are you getting into? So let me talk while that water's going. And using my own advice, I'm going to sit down and I have a problem. So my problem is, and we're going to say this is going on the Silky house. So I have my Silky house. I'm building their little house, nesting boxes and all. And I need some automation in there, as well as some light on a schedule, because I want my Silkies to be laying eggs. We're saying hypothetically, I want my Silkies to be laying eggs year round so I can sell them. So they need 12 hours of light a day. So I need to make sure that in the different times of the year when there's maybe not 12 hours of sunlight outside, and when naturally those chickens would stop laying in the fall and winter, I want a light inside to keep on. I also want light in their house so they can move around in there when they're in there if there's bad weather. I want a couple of fans in their house and some doors to move up and down. So I'm going to build a small 12-volt system. Now tonight, for our needs, I only need it to power a small light. So I'm not going to have to worry too much about how quickly it's going to drain my battery. And I'm not going to do the math on it because I'm moving kind of quickly. Quality control says tested. So what I have here is my 12 amp hour, 12 volt battery. We're going to be building a 12 volt DC system. I have my light and my component, right? I've got my battery. And I'm going to go ahead and my system, I Solo. Is it time to go grab the coffee? Yes. And let you outside? Okay. Just a sec. Hang on. Okay. You guys have to bear with me. Pause for one more second. Come on, Solo. Come on. Down. Let's go outside. Let me throw you out and grab my coffee. And I'm assuming y'all can still hear. So, going a little bit larger. Reactivators, or light. That's not a whole lot of power. For 200 watts, but 100 watts. I found that because if you have like 3 cloudy days in a row or something, you're going to deplete that battery a lot quicker than you're going to replenish it with the panels. Okay, did everyone hear me still? So I'm going to be connecting a 100-watt solar panel to this. The one I will be adding a second battery. So my wire gauge is going to have that in mind, and they will be wired in parallel, so it's still 12 volt. I don't have my second battery because thank you very much, Mr. Landfill, because I didn't buy it. So we're just going to do the one tonight. Oh, that coffee is amazing. Okay, cool. So let's get right into it. I'm going to get my crimping tool. I'm going to start making my connections. First thing we are going to do is we're going to connect this battery to our solar charge controller. Solar charge controllers come in several different types. This is an MPPT, which is a very good one. Solar charge controller. This one is at 20 amp, I believe I said. So that means the solar panels going into it can only be at 20 amp. This 100-watt solar panel runs at 8.9 amps, I believe it is. So I'd say for simplicity and to round up and to be safe, 10 amps. So 10 amps going into this 20 amp solar charge controller, just fine. And because I'm going to be doing 2 batteries, the wiring I'm going to be using, eventually I'll have the 2 together, but it's the 12 gauge. I want to make sure that I'm doing the smallest distance between the battery and the solar charge controller, and the solar panel and solar charge controller and the components. So you want to keep your wiring as short as possible. For this build here, I'm just kind of going to be making some sample wires because this isn't out where it's going to be, so I don't know the exact lengths. And to be honest, those wirings are already done. This is just for the video. So it can be very short. So for the sake of this video, my wire, I'm going to make it this long. So that is pretty short. But where this is sitting right here, that will be just fine. So I'm going to take my wire. I'm going to take my wire strippers and cutters, and we're going to cut a piece off. This is my copper wire. And if you look at the end, the camera, you probably can't see, but if it's aluminum or aluminum core, you'll be able to see that. So we're going to split this. And what I'm going to be doing is putting on some ends first, so that way I can connect it to the battery. Right. Let's get this. This is where my live stream is going to break down to being a whole lot less formal. And I'm just going to be building this little system. I've done a video in the past building a small solar generator. These are videos I want to revisit and do more. Like I had said, June is going to be solar month around here, according to my schedules. And so there's going to be a lot of videos on it. I'm starting to work on them now, so that way I have it prepared for them. Remember, if you buy solar panels at different times, they need to have the same power numbers. Yes. Oh, yeah. Great point. So part of the compatibility too, and this is with the batteries too. I'm glad you said that. When you are linking solar panels and batteries together, Steve, yes, you wouldn't want to link like a 100-watt solar panel and a 75-watt one, like you said. And if you're doing a solar array, you want them all to be the same. Otherwise, it's going to default to the lowest. So all 100-watt. With batteries, you want to make sure they're the same as well. So when I connect these two, they're both going to be 12 volt, 12 amp hour. I wouldn't want to connect a 12 volt, 12 amp hour to a 12 volt, 35 amp hour, like this one. You're going to have a lot of problems. Also, when you connect the batteries together, I'm going to use my charger, and I want to make sure they're both charged and at the same level, pretty much. It's kind of just some important things. I'm glad you brought that up. So I'm going to use my wire strippers here. And we're just going to strip off a little bit of the insulation on the end. Not that much. That might be too much, but we can cut it down. There we go. So in the video, I'll zoom in on all this, but then I'm going to take my wire crimpers and we're going to cold fuse some ends. I think that's what you were saying, right, Steve? You want to make sure that you're mixing them together. Now, when I first started doing my solar system as well, and I put solar lights out in the chicken coop, I actually did that. I had a 7 amp hour battery and a 12 amp hour battery, and it caused a lot of problems. Okay, let me think. All right, so I'm going to need my little end here. Now, let's see which camera. So these ends connect on to the battery like this. So those will wiggle on in there. They have a top piece that I can connect something else to it, like a meter or something like that. And I'll show that in a minute. How well you can see that. So now I know these fit. That's the proper size. And these are proper for my wire. So I know, let's see, I can take a look at this, and this is going to tell me that these yellow ones here are the proper size. Where does it say? Oh, on the front. Okay, so the yellow connectors, it says here, are good for 10 to 12 gauge. The wire we're using is 12 gauge, so I know my connectors are going to work out well. There we go. So all I'm going to do is I want to put my wire into the connector. You do want the wire to come out a little bit on the other end of the connector. And then I'm going to take my crimper and we're going to put that in to the proper one. Oops. And I just squeeze that down, and that's going to crimp on that end. So this is the best way to do it. You can put a piece of heat shrink on there if you want to heat shrink down, or a little bit of electrical tape around the end of that as well. So I want to do that for both sides. So we'll just push that on. That into the proper slot. And we're going to crimp that down. Real good. There we go. Crimping that's going to give that a real nice tight connection, so we're not going to have any problems. So now I can connect my battery just like that. Oops, I put that one on upside down. That's okay. All right, so now I need to make my ends that are going to go into the solar charge controller. These don't need a piece crimped on, but I do need to take a little bit of this insulation off. Ooh, it's getting hot. Okay, so I'm going to pull a little bit of this insulation off. Oh, you know what? I almost forgot. I don't have the proper size fuse. So on these smaller systems, it's not quite as big of a deal. One thing I did not get, though, was the proper size fuse. You heard that button coil? To go between the battery and my solar charge controller. The solar charge controller does that a little bit on its own. It will stop things if there's an issue. This is such a small system that I'm not going to worry about that fuse too much. But normally, you would connect the fuse the closest distance to the battery as you can, either on the terminal, like on these bigger ones, directly to it, or very close to it is where you would put your fuse. All right. Oh no, you know what? Something else I did not grab that if I went to look for right now is a small screwdriver. So the solar charge controller has some little screws here. And these little screws need to be loosened so I can put the wires in. I don't know, well, you can see on camera, but these first two slots are for positive, negative on your solar panel, positive, negative, the battery, and then the load out. And so I am going to need to find a small screwdriver. That was something I wasn't prepared for. So this was another thing I was kind of scared about doing the live, was I'd end up with something I needed and not be able to find it. If you woke up in the morning and you find your second system set up, you know they paid attention. Oh, the button quail. I was wanting to show them and talk about them too, but I'm going to end up having a really long stream. Let me look here real quick for the screwdriver and let me see if I have one right here. Otherwise, I'm going to have to use improper tools. I know where one is outside. It's in the Silky house. I might need to run out there and get it. Okay. Well, if you're still here, you've been here this long. Oh, look, I didn't talk about like battery meters and stuff. Okay, that's okay. If you're still here, hang on another minute. I got to go grab a screwdriver, otherwise I keep it. I do want to mention while I'm walking, I guess, side note, we've been working on some really cool things for some stuff coming up here. And just give you a little head solo out. We've been getting some things, we're going to get some things 3D printed, and we've got some cool stuff, not necessarily for, it's not for sale. Oh, I don't want to spoil it. We'll have to get into that later. Okay, cool. Got my little screwdriver. I'm going to go ahead and I want to unloosen the screws here to the middle ones. This is my battery. So I guess I mentioned a little bit. In April, we're going to be doing kind of a fundraiser. We have some special items for sale. Some really cool things coming out, and I think it's going to be April. And we're going to be doing not a fundraiser, but a drive to get us to QuailCon, me and primarily Farmer Casey, get him there with me again. So we have some special items we're going to be selling and doing giveaway type things. I don't want to spoil it, but got some cool stuff coming up for that whole month to help with our shop and all, to help with that. But with that, there's some very unique items, some pretty neat things that I'm excited about that will be given out to people. I was talking to the individual who is helping me with that earlier today, and I'm super excited. Okay, cool. And so what I'm going to do is I'm going to go ahead and connect my wiring here. We'll put our negative. And so I just want to push that wire in as far as I can there. And tighten this down. And that's going to hold it in place. These do get loose over time. So every now and then when you come and do maintenance on your system, say I'm pulling that's pretty good. You want to make sure that all this is tight and there's no problems. You don't want anything falling out and touching anything. That in there. I'm going to screw that down. I don't know if you guys have heard of button quail's noises, but they're different than Quaternix quail. They make this little laugh, like, I don't know how to explain it. It's really funny. They don't have the same sounds as Quaternix quail. They make very unique sounds. My wife doesn't like it. She says it's creepy. It sounds like Elmo laughing from the other room. All right, so this is connected to our solar charge controller. We want to make sure we got the battery first. Once again, we're going to talk positive here and negative here. Okay, now that I have it to the battery, you should be able to see something going on. If the camera will get it. So I don't know how well that's picking up, but you can see here now, it's reading out that I am getting 13.7 volts. On your system, a 12 volt system, 24 volt, whatever, you're not going to get 12 volt 24. You're going to get 13.7, 12.8, 24.8, something like that. It's going to be in a range, in this case, from 12 to 14. So that's good. This battery is not all the way full. And it's saying it's got something going out, but nothing is. So I can turn what goes on and off and do different things on here. So the next thing we are going to do is actually we're going to go ahead and hook up our light or our load. And I'm going to run it through a timer here. So what I'm going to do is I'm going to show you how to wire up this timer. We're going to run the timer into the load slot here. Let's jump around a little bit. The timer into the load slot, into the load, and then the light into the timer. Then I'm going to connect a wire, and I'm not actually going to connect the solar panel, but I'm going to show you how to do that. And then this is basically going to be ready, minus the wire length and all that. You'll run your light or a fan or whatever have you in your coop or hutch or what have you. And then this, you can basically take this idea or what I'm doing here and just upscale it and do it on your own. But I want to get this light to turn on. So here I have my timer. On the back, there's a diagram. And I'm willing to see that. Okay, and so basically how this works is I'm going to feed power in, well, here, it can work a couple different ways. So I can have a smaller source power, just like the relay, trigger it, and then it do a different power. Or in this case, all 12 volt. Okay. So this one comes with some little wires and connectors, which makes it nice. I'm going to look at my little diagram here. And this is for a 12 volt system. So my little diagram is going to tell me which pins to put these wires on. So here we got pin 1, 2, 3, and 4. And so pin 1, 3, and 4 are all red because those have to do with power. And the black is going to be your neutral. So we're only doing 12 volt. So number 1 and number 3, we're going to go ahead and put together. If you weren't just doing a 12 volt system, then the 12 volt would go to this one. And whatever volt you want on the load, 5 volt or whatever, would go to here. Because they're both 12 volt, we can put those together. This one that's missing, this is our black wire, so that's just going to be our negative. The negative from the light will need to connect to here, as well as this is going to need to connect to the negative on our load, either the battery or in this case, the charge controller. The final wire here, the fourth one, this is the one that's going to feed power out to the light. So that way when the timer clicks on or off, the light goes on or off. So what I need to do here first is strip the two ends of wire 1 and 3 on here just a little bit, and we're going to twist those together. And here I'm not going to use the crimper. I am just going to twist and do a little electrical tape. I would normally want to make sure I solder or crimp that, but excuse me. But I am going to be honest with you, I'm getting pretty tired. I am trying to move it along. So it's kind of hard. I know how to do this stuff, but being able to explain it well is kind of difficult. Okay, so 1 and 3, we're going to go ahead and wrap those together. So that's power into the system, and then the power that's going to go to the wire to the load. Both 12 volt, all 12 volt. We're operating in all 12 volt here. And so I'm putting a little bit of electrical tape on there. Oh, wait, just kidding. I don't want to put electrical tape on yet. We twisted those together, and these are going to need to go to here. So I need another wire. So I'm going to go ahead and grab some wire. We don't want our large 12. I'm going to use a little bit of the smaller wire. Where is it at? I'm going to use my 18 gauge. And so this is good for like speaker wire. I think this is speaker wire, to be honest, but it's copper wire. There we go. And so I'm going to take a piece of that. We don't need it too long because we're just operating on the table here. Building these systems is a lot of cutting wires and just sitting here and doing things like this. I think it takes a lot of the time. So I'll just take off that insulation. And then we're going to remove that insulation. Oops, pull my wire through. So the wire, you're going to have the core, the metal core, like we talked about. And then you're going to have the insulator on the outside. That's what I'm taking off, the plastic. And that's so that the way your electricity doesn't escape, much like a hose. That way your water doesn't escape. Start arcing and going everywhere. All right, cool. So I can take my positive on the end of my cord here, and I'm going to go ahead and connect that to 1 and 3. And this would either go to the battery or the charge controller. Oh, you know what I don't have wired in here is my fuse box. This is really simple, so I wouldn't necessarily do a fuse box. I would just wire it right in here. But I'm going to do a fuse box because I wanted to show. So this is that simple 12-volt fuse box. And this would go in between the charge controller and the light and switches and things like that. So let's wire this one in first. Now this is going to carry a little bit more current than just like the lights and stuff, because this is carrying all the current from here to here, and then it's pulling from all the different devices. So on this, I am going to go ahead and use the bigger wire as well. You always want to use bigger wire when you can. All right, and so we'll just take a piece of this. We still got 3 people. You guys are troopers. I'm about to fall asleep. I'm gonna be honest. There's so much into electrical theory and how it works and all. I really need to do a series. Or maybe just in a video, I can get it all across quicker. Okay, so I got my wire piece here, and all I'm doing is I'm splitting the 2 ends. I'm going to strip them down. Go. I'll strip both ends. One of the things I'll do, like when it's cold or night and I want to work on my system, like out in the quail house, and I want to be doing some of this, but I can't be really working on it. Sometimes I'll just sit and I'll make wiring harnesses for things, cut the wiring, put the ends on, I put the little connectors and things like that. That way I could just take them out and plug them in, and it makes it much easier. Okay. So let's go ahead and get this. I'm going to need to cut the insulation on the ends that go on the fuse box a little bit longer, because it's going to be wrapping around. Oh, you know what? I don't need to do that. I can crimp them. Okay. So I got my wires. I am going to crimp these. I forgot. I have these other ends here. So I got these ends. They have a little round circle. And so we're going to crimp these on. may not have been the correct size of the little circle. They have a smaller circle. Yeah, that was probably the correct size. That's all right. I'm going to use that. Okay. There you go. Okay, so get those curves on there. That's the correct size, but that's all right. These are going to go ahead and go. I'm going to split these wires. These are going to go onto my fuse panel. You know, when you buy the fuse panels, you can get ones that have both positive and negative bus bars. That's a negative bus bar, and these are positive. It says both. You want to make sure you get one that has both. Oops. Try and loosen this. There we go. Or you can get ones that are separate. So a lot of times, like on the bigger systems, you'll have separate bus bars. You'll just have a big positive and then a big negative, and you just have all your wires go in there. Getting sleepy. We're going to get this light to turn on via timer. Okay. That bolt off. We got our positive wire and our connector. I'll put that down. I'll put our washer, our lock nut. I'm going to screw that down. There we go. Do the same over here, the negative. So the negative positive bus bars, you may want to make sure things don't touch. I end up with so much mess everywhere when I'm doing this. I always end up with wire pieces everywhere, and let's see. And not my wrench with me either. Tomorrow, if you are on here still, we're not doing a live stream tomorrow because of this. However, tomorrow our schedule for February is going to post. So all of the live streams and videos and all that we plan on doing at least will post tomorrow. Okay, so we'll go ahead and we'll put this, which is a little too big, but we'll put that on there. It should be all right. I actually really should change that, but I'm not going to do that right now. It will connect. The reason is it's too big, it's going to create loose connections. So if this was up on the system I'm using, it may not connect all the time. So I would change that to a smaller one. I'm not going to right now. Okay, so now I got that. I'm going to want to connect our little fuse box into our solar charge controller. So that's going to be over here on the load side. And we got positive and a negative. And this thing does have power going to it. Yeah, Andy, I don't blame you. I'm falling asleep sitting here. You have a good one. Thank you so much for showing up. Watch later if you'd like to finish it up. Otherwise, I am going to do this in a video, even this smaller one. I'm going to release a series of videos explaining this better. Tonight, by making you guys an experiment or by saying that, it's really for myself so I know what works and how I need to approach this. I really just needed, that's why I did it in live, but I really just needed to jump in and start doing it on the live and trying to explain, and then I'll know how to do it better later. But you have a blessed night. Thank you so much for showing up. Okay, so we're going to put the positive into the positive here. We're going to throw our screwdriver. You're glad to be my guinea pig. Well, thank you. We appreciate that. But I am actually in my head as I'm doing this, I'm thinking about, okay, so this is what I need to explain. This is how I should format my explanation, I guess, or my Hopefully you're learning something. It's not hard. It does take some planning, somewhat. Or you can just make a really big system and plug whatever you want into it. It just costs a little bit more. So this now has power going to both of these. So if I touch these, it's probably going to hurt. However, if I connect something to it, it's not going to have power because there's no fuse in here yet. So I'm going to take my, I'm going to go ahead and take my timer. I should have finished stripping these wires before I connected in. There we go. Okay, so I got my 1 and 3, according to my diagram here, connected to the positive, to the red there. The black over here is going to need to connect to the black. The other thing that I always forget when I'm just going to twist these stuff. That I always forget when I'm doing this is I will twist them up and then put tape around them and all. Is the black. You also need to connect your like light or whatever to the black as well, or just to the black on the battery. And in my chicken house, how I have it set up is there's separate wires going to each, and I'll have to show that really. Okay. This isn't the proper way. You should be crimping and things like I was doing. But right now I'm twisting. And I'm going to throw a little piece of electrical tape in between here just because these are real close together. I don't want them touching. I'm going to put it on the positive because I still need to get to that negative, like I said. And I could just connect the negative right to the battery, but I'm not going to do that. Okay. That is not done well, but that is done. Hopefully that will hold. There we go. Okay. Now I got my wire. I need to strip down more. Oops. You know what? Looking at this wire too, this isn't copper, this is aluminum. But it'll work. It's not ideal. It's just the wire to the light. It's not the main wires, but still. Okay. So there we go. And I could put ends on here, but I'm not going to for right now. So I have my negative down here, my negative bar. And so I can unscrew one of these. It's really, when they're brand new, they really crank these screws down. Other screwdriver for this part. Oh, stand up. Oh, I'm getting old. I'm getting tired. All right, I need the other screwdriver. I got it sitting around here. I'm going to have to get the bigger screwdriver for these screws. I think I have it just over here. Nope, I put it somewhere. No, I might have to do it with this one. Okay. So you'd unscrew that screw, and you're going to connect this. I am not going to unscrew the screw. I'm just going to kind of connect it on there for now. I'm getting tired. No, I gotta unscrew it. Let's see if one of these other ones is looser, maybe. Oh, no, there we go. It's going. Slowly. If I had the proper tools, this would be easier. And also, if this was screwed to a board or something, it'd be easier because I'm not worrying about it moving around. Oh, that's not turning. Is this one looser? Should have done this first. Okay, we're just gonna have to kind of loosely connect these. I'm gonna have to be really careful. So you want those under. Okay. Might have to go find the other screwdriver. I think I am. Okay. Well, sorry about that. I'll be right back. Okay. Oh, where that went? Let me see. Always overlook things. Solo out. Go on. I'm almost done, bud. He's very concerned. Go. So loosen that. Look how easy. Proper tools. Make it go. Okay. So now I can put my negative on here. And normally I would do this with the proper connector and all that. And we'll tighten that down on the wire. Under the washer so it will tighten down. There we go. So I've got my negative under the negative bus bar. And that runs into the timer. Already connected on the load. All right, got that on. Now I got my positive, and I didn't leave myself very much cord here, very, very small. I should have cut a little more of that insulation off. That's all right. I'm gonna unscrew that. 6 people. Hey, look at that. You guys are crazy. What time is it where you're all from? So here it is 10:14, and I am up quite a bit later normally, but Saturdays and Fridays I get tired earlier. I don't know why. Oops. This wire is very short, and I'm trying not to pull out the negative one. I don't know if I'm doing the best example here of this. There we go. So as a kid, I used to have capsulas and connector sets and things. Capsulas were cool because they really involved electricity a lot more than the connector sets. 11:14 Central Time, 12:14. Wow, you're a trooper. It's already tomorrow there, Mr. Landfill. Well, thank you guys for staying. You guys rock. All right, let's see. So I got that connected. We're going to need a fuse in here. Now, fuse size is important. Once again, it is 1.25 times the amps used. So if this light is using a 1 amp, I'd want like a 1.2 or 2 amp fuse. You don't want to go too much higher. This is very much higher, but it's what I grabbed, and it is going to work to connect them right now. And so I'm going to put that right in there, and that's going to connect these two. So now all I need to do is connect my light to the negative and the positive here on my timer or my switch, and then I should be able to turn the light on with this switch. The only other thing we didn't do is the 2 cords here on the first. That's where I'd plug my solar panel in, and I could do that last. You still have your old capsula set? That's cool. I loved capsulas. I had so many of them, and I would make things and flashlights and motors, and I'd take them apart and use them how they weren't supposed to. And that's where I learned about connecting batteries and how I could, with double A's in particular. Okay. So here we go. We have our negative on the timer. The second cord is connected to the negative here in the bus bar. I'm also going to connect my light negative to that. So I need to strip that down a little bit more. I like talking about capsulas and things like that to people, and most people have no idea what I'm talking about. So that's cool, Mr. Landfill. I've shocked myself, I don't know how many times. Maybe that's what's wrong with me. No, I'm just kidding. And I do encourage, I guess I'm not really supposed to say because you should do things the right way and all, but I encourage people just exploring and having fun and be safe. But, that's how I learn all this stuff, is just by messing with it. Most of it I learned before internet, so what I know is may or may not be right. I don't want to say that. No, I think it's right. All right, so I got my negative there. My positive is going to go here. And you notice the light has not come on. So we've created a circuit, but where it's broken is in here. So this, I can now set to timer to come on or off or do whatever I want it to do. But what I'm going to do is just turn it on. So I'm going to unlock it. And I'm going to turn this manual to on. Now it's on, but this isn't getting proper power. Oh, you know what? I have it turned off here. So this solar charge controller has a little button here, and I can kill all the power to everything coming out of the load. That's important in case you need to turn it off. I like it because if it's a really sunny day and I have the windows open, and I think this happens quite often, and I'm like, let's give the solar system a break. Let's let those batteries just charge up today. I'll hit this button and kill all the power off. That way it's just charging up, and then I'll turn it back on later. So I'm going to turn this on now. Let me turn this off, actually. So timer is off. So there we go. Power goes to the load, so that should be going in here and everything, and then I should be able to turn this on now. Ta-da! So I turn that on. You see my light come on, off, and then right now it's on auto, which means the timer, whatever I set that to, program that to, will come on and off. So we'll turn that on, and then if I pull this fuse out, so that fuse trips, ta-da, then that's going to trip. And this one has a little light, I don't know if you can see, but it comes on the fuse panel to tell me it's tripped. No flames, no positive smoke test. So in computer repair class, they used to say, you got a positive smoke test. You don't want a positive smoke test. So no positive smoke test. This is a very simple system. It works out. One of the things I didn't talk about, but I was just going to mention, that I use quite a bit, is these little battery meters. So this I can connect right up here to my battery. And I'm just going to touch them right now, but positive, negative. And this is going to come on, and this is going to give me a little better readout than my charge controller. So this actually says the battery's at 100%, 13.4 volts. Awesome. So this could run, and I'll see how long it's going to run at 1 volt. This will discharge this battery. I'm sorry, if this, for simplicity, if this light is 1 amp at 12 volts, that's 1 watt hour. This battery here is 12 amps, and you only want to discharge 50%, so we'll say 6 amps. So at 1 amp, that can run. This light can run for 6 hours before this battery goes below its power and turns off. So 2 of these batteries would give me 12 hours on this light. Now, I'm not going to be running that for 12 hours. It comes on and off with this timer for a few hours in the evening and a few at night. But that's how you can do it. Cool. The only put limited supply of smoke in components. Don't let the smoke out. Yeah. You have them for boat batteries. The meter is for the battery, yeah. You guys rock. Thanks for staying. So this is my talk on solar, my little build. We'll do this later. Hopefully, you guys learned a little something or got at least some enjoyment out of it. I'm actually beat. I'm very tired. Um, but thank you very much. So I know we got Mr. Landfill, we got Steve in here. We got 6 people, it says. So for all of you that still stayed, you are troopers. There is no live tomorrow, but I am going to work on getting this video out, and so we'll be doing that. So I'm just gonna leave. I'm gonna for a couple minutes here, just leave comments open before I hop off. Very good, Steve. I haven't experimented with much bigger systems yet, like whole house ones. So I know like Willie had asked me on that and was wanting me to help, but just not experienced. You guys all be safe. When you're doing this, make sure you go at it with safety and do your research. Make sure you're using insulated tools and things like that. I'm gonna go ahead and hop off. You guys have a good one. Thank you very much. Appreciate the friendship and fellowship. Until next time, we'll see you guys later. Have a good one.